All right, so the story was the point was 1, 3, and the line, what was the line? Y equals
Negative
2x plus don't care, right?
No, isn't that 4?
Yeah, but I don't care.
Oh.
Because I just need the slope, right?
Yeah.
Okay, so, because the slope of this line is negative 2. Do you agree?
Yeah.
So therefore, since we have parallel lines, the slope of our line is also negative 2. Is that right? If it's at perpendicular, what would be the slope of our line? Half. So you flip it and change the sign. So negative 2 becomes positive 1/2. Okay? Quick way to check, if you multiply the two numbers, you should always get negative 1. The product of the slopes of perpendicular lines always negative 1. Negative 2 and 1/2, negative 1. Right? So, okay, so we have a slope equals negative 2, and the point is 1 comma 3. So then, the way I like to do that is to use the point slope form. And then I have all the information. I have 3 goes in for y1, 1 goes in for x1, and negative 2 goes in for m. Plug it all in and simplify that. So y minus 3 equals negative 2 x minus 1.
So you wouldn't put the 4 for y1?
Oh no, that 4 is really irrelevant to me.
Okay.
That's just because that's the y-intercept of that reference line, so I don't really care.
Is that 4 like the y-intercept?
Yeah, that 4 was the y-intercept of that reference line, so I don't really care where it's at. All I need is the slope of that line. That's the only piece of information that I really worry about. Does that make sense? So that y-intercept of the reference line is irrelevant. It doesn't do anything for us. Well, now we'll just simplify this. Plus 2, add 3. Is that good? All right, that's about it. Now, what was the other question?
B on number 6. We have to find the star.
Oh yeah, those are fun.
Yeah, I just didn't understand the time. We got the right answer.
Are we good with the line?
Yeah.
So what was the question with the star?
I don't have the, I have like the problem, I guess. 15y plus star equals 225y squared plus 12x cubed y plus 0.16.
Plus 12x cubed y plus
0.16x x to 6. X to 6.
x to 6. And I'm sure there was a square over here.
Yes.
Right?
Yeah, it's squared.
Okay. So that's basically testing those two formulas that I gave you last time, and this is kind of working backwards. And this is just a fun exercise. Just if we can do that, it'll really help us just to do regular problems when we square things. Does that make sense?
Yeah.
This school's calling all of us. Yellow.
Wow.
Oh yeah, I'm getting involved.
Thank you.
That's all it becomes the same. Lockdown is actually over now.
CNC needs a Grammy in a minute. Yeah, yeah, Bill comes on in a couple minutes. Go.
Thank you very much.
Everybody is like, only a few minutes later, you get my email here to say lockdown.
Okay, where were we? So again, we're just trying to match this with our formula. Right? So really, we're just looking for B. Okay, that's the thing. That's what the star is. It's a B in this formula. And the easiest thing to find that B is to kind of look at that last thing. Because I know what B squared is, right? B squared is 0.16 x to the power 6. So if B squared is 0.16 x to the 6, what is B? 0.4 x cubed, right? If B squared equals then b has to equal 0.4 x cubed. Because if you square that, you get that. Does that make sense? And you can, that's really it. That's so the star is 0.4 x cubed. And it works here in the middle too, because remember what the middle is. Middle is 2 times a times b. So if I compute that, 2 times a is 15y, and b is 0.4 x cubed. 2 times 15 is 30. 30 times 0.4 is 12. So that does in fact comes out to 12x cubed y. So that matches that middle term as well. This is just to really check your solution with that works. So that's what the star is. You're really just matching it with the formula.
Curious though, since
Yeah.
how we're going to have it squared, so it's a 0.04 x cubed, would we have a parentheses with a squared on the outside of that then?
No, that's what b is. The b squared would be having a parenthesis on the outside of that, and when you compute it, it gives you 0.60. Does that make sense? It's just a fun exercise to play with those formulas. Anything else? Good? Let's draw a little quickie. Yeah, I'll just turn it in. And I'll post the solution to that as well, and hopefully grade it together with the other worksheets.
I don't have a stapler, so I just folded the edge, but my name is on both of them.
Okay.
Sorry. Thank you.
Stay with it.
Nope, just throw it on there.
Careful, because if you do this, that's that. They'll still together. They'll still together like that.
Is it okay, do you want these stickers together or just?
Well, if the original doesn't have anything on it, then I'll just yeah. I don't know. I was now something I gave out. Let me know if I need more. You didn't get one?
Oh, totally got them.
We got one? Everyone's happy? You want? Oh, you did one. Yeah. So you have one.
Yeah, that's what you were asking.
Oh, okay. I thought you needed one. So everyone has one.
Yeah.
Is anybody score counters? Or this one? There's no name here. No name?
Oh, I think that's Smith.
So if you read the instructions, what does it say?
Evaluate the following numerical expression.
What else does it say?
Use the difference of squares.
And what does it say on the very top?
No calculator.
Right. Because every time you have the urge to reach for a calculator or you start doing some really complex computation, just stop right there and rethink your approach because you're probably missing the whole point of the problem. Because there is a quick way of doing that, and I'm saying this in the parentheses. Use difference of squares formula, right? Because if I do that, see what happens. If I use the difference of squares, and again, difference of squares is that the a plus b, a minus b equals a squared minus b squared, right? So I'm already looking at something squared minus something squared. I already have my little squares, right? So I'm actually staring at this part of the problem. Can you tell me what is A and what is B? What is A? 26, and what is B? 12. And same thing for the denominator. We have 54 and 16. So right away I can do this. 26 plus 12, 26 minus 12 over 54 plus 16, 54 minus 16. Right? So right away, using the difference of squares formula, we can do that. Well, now let's start computing those little parentheses. What is 26 plus 12? 38 times, what is 26 minus 12? 14. And what is 54 plus 16? 70. And what is 54 minus 16? 38. All right. So far? Is it good? Well, now look at this fraction. Both numerator and denominator have 38 in it. It's 38 times 14 and it's 70 times 38. What can be done about that 38? I can just cancel because that's a common factor. 38, 38 cancels, right? What can I do about 14 and 70? Yeah, I can divide by 7 at least. Or I can actually go ahead and divide by 14. Because 14 goes into 70 how many times? 5. So right away 14 is 1 and 70 is 5. 1. Right? It's a lot harder to do it with a calculator actually, because you get really large numbers and then you try to reduce that, and that's even harder. Okay? I'll keep giving you this question on the quizzes till we get it. So a few, 2-3 quizzes from now on, you'll have something cute like that where you can throw that formula in and we'll get it. Is that okay? I didn't need a calculator. All right, now I saw that everybody was kind of okay with this problem. Let's just using our square root difference formula straight up. So what we did on Tuesday, we take the first number, we square that. That's 4x squared, right? Then, since the parenthesis has a minus, we're going to put a minus there. Then for the middle part, I'm going to multiply the 2, gives me 6, and then double that, 12, so it's 12xy, and then plus last squared, 9y squared. That's it. Is that okay? Fun. Okay, good. So, but yeah, we can use this difference of squares formula to multiply fast and to factor. And that's what we're doing here. We're using it to factor. Later on, we'll be using these formulas to factor. I can give you something like this long trinomial, and ask you to factor that. And it's really hard to factor if you do not use that formula. Because if you recognize that you have a perfect square here and a perfect square there, then maybe some good things happen, then automatically it factors into that, which is a lot easier than going through all the factoring steps, because there are a lot of them. But later, okay? But for now, when I ask you to factor, and usually when you ask to factor, we mean to factor completely, meaning factor till you can no longer factor. Because a lot of times you take one factoring step and you can go further. Okay? So factor completely. Factor until you can no longer factor. Well, not you personally, no one can. No longer factor. I don't know if that makes sense. I don't know what I'm trying to say. So again, an example. If I give you x squared minus 4 and ask you to factor that. Now, can we factor that? How would we do that?
X plus 2, then x minus 2.
That's right, because you recognize that that's a difference of two perfect squares. So the difference of squares formula applies. So that gives us x minus 2 and x plus 2. And now when you look at each of those factors individually, you cannot factor it any further. We're done. Okay, so we're done. That's the answer. What?
Oh no, I was trying to relate this to the board for Tuesday night, and I just don't understand. I understand this.
Okay, but if I ask you this, here we go. Is that the one? That kind of thing?
It's x cubed plus y cubed.
Yeah, we haven't gotten to that formula yet.
Oh, that's our homework.
Yeah, but it's for Thursday.
Gotcha.
Yeah.
Okay, I'm understanding now.
But yeah, that's good. Is that the only one you stuck on?
Yeah.
Well, then it's really good because I haven't talked about it. But everything else is good. How would you proceed factoring? Because every time you see an even power, you can think of this as something squared. I can think of x to the power 4 as what squared? X squared squared. So I can actually, you don't have to write this down, but I can think of this in those terms. It's x squared squared minus 4 squared, right? That's a difference of 2 squared. So x squared is playing the role of a in my formula, and 4 is playing the role of b in my formula. So I can split it up using difference of squares formula to write it as x squared minus 4, x squared plus 4. Same as before. A minus b, a plus b. Is that right? But now ask yourself, can you factor further? And the answer is yes, because we just did that. We did x squared minus 4. We know that splits into x plus 2x minus 2. But x squared plus 4, we cannot factor that. We do not have a formula for the sum of squares. I think that question came up on Tuesday. So every time you get stuck with a square plus a number, there's nothing you can do to that. So you're just stuck with x squared plus 4. We won't be able to reduce that, unfortunately, for now. Maybe in college algebra we'll learn a sneaky way of doing that. But we need to step outside the world of the real numbers. Real numbers are not sufficient to factor. So cannot factor the sum of squares. So a squared plus b squared cannot be factored. So the answer here is x minus 2, x plus 2, and x squared plus 2. This is as far as we can get. Is that okay? So that's what we mean by factor completely. And you'll see a few questions like this on the worksheet where you kind of, yeah.
Why can't you factor the sum of squares?
Well, I'll tell you this. In order for me to factor the sum of squares, and I'm going to say this phrase, I'll need to be able to take square roots of negative numbers. Kind of a weird statement, but that's kind of hard to do. Okay? Just don't write this down, but if I say, and I'm jumping ahead a little bit, if I were to ask you, and I know we haven't talked about it, but you might have seen this before. If I ask you to solve this equation, how would you go about this? All right, that's one way. So you would add 4, and then you would take square. How many of you know about square roots? By the way, that's not official knowledge yet. We'll learn square roots eventually, but you've seen them before. So yes, you would take square roots of both sides. So you have x equals, you have to remember to put plus or minus in there. We'll talk about that. But square root of 4 is 2, and we're very happy. So it has two solutions. X equals 2, x equals negative 2. Is that okay? The other way to solve this equation is to factor it first. And then you have a product that equals 0. That means you're multiplying by 0. So we'll set each factor to 0. And we get x equals negative 2, x equals 2. So we get the same solution. Okay? So basically, if you get nice, pretty solutions, that means this expression can be factored into nice, pretty factors. Because there's a big connection between solving equations and actually factoring. That's why we're spending a lot of time on factoring. Are you with me so far? All right. But if I put this problem here, and I try to solve that, if I follow the same steps as here, move 4 to the other side, what do I get? X squared equals negative 4, right? If I follow the same steps, I would have to take square roots of both sides. And here I am taking square root of a negative number, right? Which is very hard to do. Some of you know what square root of a negative number is. We don't yet in this class, so it's not a real number, nothing else you can do. So this equation does not have any solutions. And with the same parallel, I won't be able to factor it. Because if I were able to factor it, it would have solutions. But it doesn't. It's kind of a weird way of explaining that. But it's just so. This is why we don't have a fancy formula for the sum of squares. Cannot split that.
So right now you'd say that has no solution?
Yeah, so no real solutions. But we will look at this equation way in November or something like that.
Imaginary numbers.
Yeah, but so not real. That's why I'm saying no real solutions. You'll have imaginary solutions, and you will learn imaginary numbers in college algebra. They're fun. You have to imagine things. Imaginary numbers. They're not real. So does that kind of answer your question? I don't know. So this is the best I can do with that. Just nothing really works to split the sum of two squares. So this is why, again, I think that came up on Tuesday. That's why we have 7 formulas. We have the difference of squares, but then the rest will come in pairs. Yeah.
What would have happened if you would have tried to start factoring that on the other side?
Well, that's what I mean. There's nothing. Even if I try, even if whatever you believe this thing factors to, if you foil it, you will not get the original thing back, no matter what you think. What do you think it might factor into? Just take a guess. I mean, we can try it, but we'll fail miserably if we try to factor this. I cannot do plus minus because I know that leads to the negative.
Negative x. I don't know.
Well, go ahead. Negative x.
That's not as far as I want to go.
All right, well, that's not enough. We need more. But again, whatever you write on that side, if you foil it, it will not equal x squared plus 4. I guarantee it. If you use real numbers. If you know about imaginary numbers and you start throwing those in, yeah, it will work. But for now, with real numbers, it doesn't work. Is that okay? I know it's sad, but just sum of squares cannot be factored. So sum of squares cannot be factored. Again, in order for us to factor sum of squares, we have to have ability to take square roots of negative numbers, which is a little shaky on the whole ethic spectrum. Okay. Good. All right. So we have three formulas. Difference of squares, square root of a sum, square root of difference. So let's talk about some cubic formulas. So I want to talk about, so that's the fourth formula, cube of a sum. So this is the formula that you will be provided on the exams and quizzes and all of our closed notes exercises. Okay? If you do your half of the bargain. Remember your half of the bargain? What is your half of the bargain? Remember the first three, I'll give you the other four. So the way we do, but if you memorize that formula, good for you. I don't require that. But the way we derive that, we understand that a plus b cubed, that means a plus b times a plus b times a plus b, right? Or I can think of this as a plus b times a plus b squared. That's same as a plus b cubed, right? And I know how to do the square. I already have a formula for the square, so that'll give me a plus b, and then a squared plus 2ab plus b. Right, because I already know how to square things. And now I'm going to do a little triple FOIL. I'll have to multiply a by a squared, a by 2ab, a by b squared, and then ba squared, b times 2ab, and b times b squared. I have to do that type of FOIL, which is really not fun. That's why we want to derive a formula. But if we do the FOIL, a times a squared is what? A cubed plus a times 2ab. What will that give? What is squared? Well, b is not squared, right? Because it's just 2ab, so that just stays the same. So 2a squared b plus a times b squared is just, well, a times b squared. Nothing fancy happens there, right? And then when I do the other half, b times a squared, I'm going to write it as a squared b plus b times 2ab is 2ab squared. And b times b squared is b cubed. So 6 terms. I can combine some, can I? Well, some of them are like terms, so 2a squared b and a squared b, and then ab squared and 2ab squared. So when I combine like terms, I get a cubed plus 3a squared b plus 3ab squared plus b cubed. So that's the formula. So this is how you cube a sum. Is that okay? This is how we derived it. We're also going to have a cube of a difference formula. So it's the fifth formula. So this is a minus b cubed Now, I'm not going to go through the steps of deriving, and I'm just going to tell you what it is because it's kind of the same process. I'll just tell you it's the same formula as above, but every time you see a b with an odd power, it will have a minus sign. Okay, so first term, do you see b with an odd power on the very first term?
No.
No, so just a cubed. On the second term, do you see b with an odd power?
No.
Well, what is the power of b? 1. 1 is odd, so I'll have a negative there. Now, on the next term, do you see b with an odd power? No, so it'll still be positive. And on the last term, do you see b with an odd power? Yes, so it will be negative. So basically, you cubing negative b, it will be negative. Here, you're squaring negative b, it will become positive. The derivation is exactly the same. You write a minus b times a minus b squared. You square first, and then you FOIL. I just don't want to do the same thing.
So how do you know if it's negative by the power? The power.
I'm cheating a little bit, yeah.
How come a cubed is?
What?
How come a cubed is?
Well, a cubed is because a is positive to begin with. Basically, what I'm doing, I'm using that formula. I'm just putting negative b for every b that I see there. So negative b in here comes out negative. Negative b in there, because of the square, becomes positive. And negative b in there, cubing it, stays negative. That's another way of doing it. So just take that formula. Again, you don't have to memorize them. They're hard to memorize. There are patterns in those formulas. If I teach you patterns, which I will later today, then they're easy to build without doing all the math. But I will be giving you these formulas. So on the top of your exams, you'll have those formulas. If I decide to give you a quiz that use those formulas, I either write it on a quiz or write it on the board. On a homework, on the worksheets, you can go through your notes. Okay, so you just need to know how to use them. You need to know that they exist. But you don't have to memorize them. If you do, good. And I'll teach you how to do it, how to build them. There are patterns. They're easy to build. Well, let me do a few examples where we use them. So 2x plus 3 quantity cubed. So I'll use the first formula, right? Cube of the sum. And what is playing the role of a in this problem? 2x. And what is playing the role of b? 3. So I'm just going to go ahead, and in this formula, for every a, I'm going to put 2x. And for every b, I'm going to put 3. That's the plan. Is that all right? That's how we use those formulas. So just literally, for every a, I'm going to put 2x. I'm going to write 2x cubed plus 3 times a squared. So that's 2x squared. Times b. B is 3, so times 3. Again, 2x is our a, 2x is our a, and this 3 is our b. And the first 3 is just part of the formula. It's always there. You always have the coefficient. We're okay in the first two terms, how I'm doing that. So third term, formula tells me put a 3. Then a happens to be 2x in this problem, so just 2x, times b squared. B is 3, so I'm going to write 3 squared, and plus b cubed. B, again, is 3, so plus 3 cubed.
Kind of curious, where and would you really use these equations? Kind of routes out of school.
Well, I mean, I don't know, every time you're cubing it, you can always relate it to volume of a cube. You're dealing with a cube, I mean, that would be some, you're trying to buy some lumber and you have a variable. If you have that in mind, or you're trying to, there are fun problems you can start maximizing the volume while minimizing the area of the surface area. So here we go. You start cubing things that have algebraic expressions. So you want to do the cubing fast. You don't want to be stuck on foiling, because that's such a minor thing in that whole big problem. So you want to just get it out of there fast. So again, this is little a, this is little b, this is little b. Is that okay? Do you understand how I do that? No.
That's okay, because I'll figure it out.
But again, all I'm doing, I'm just literally putting for every a in this right side, I put 2x, and for every b, I put a 3. That's all I did. In that formula that we just derived, for every a, I put 2x. For every b, I put a 3. That's all I did. And now I'm going to actually compute that. So 2x cubed, 2 cubed is 8, and x cubed, so I have that. Plus, so what's going on in the middle? I have 2 squared. That gives me what? 4 times 3 is what? 12, and then I have another times 3. 36. So coefficient is 36. The variable is x squared, because you were squaring that. If you actually compute that, this is 3 times 4 times 3. What about the next one? 3 times 2 is what? 6. And what is 3 squared? And what is 6 times 9? 54. So this is 54x. And finally, 3 cubed is 27. So there we go. Well, those are not like terms. They have different powers, so that's it. We're stuck with that. Cannot do anything. Is that okay? So again, the second you recognize the A and the B, you just put them in your formula. Okay? I had students who would do this. Let's say I would give them this problem, 3x minus 5. 3x minus 5 cubed, and they'll just right away do this. They'll write cubed minus 3 squared. They'll just put those little parentheses minus here. And they'll just fill in the parentheses. Because this is the formula. A cubed minus 3a squared b plus 3ab squared plus b cubed. And then you just recognize what's a, what's b. Do you see that? This is the formula, just placeholders? So what do I put in this parenthesis? 3x. What do I put in this parenthesis?
3x.
What do I put in this parenthesis? 3x. So we're done with 3x. What do I put in this parenthesis? 5. What do I put in that parenthesis? And that parenthesis. 5. So that's it. That's the setup. That's kind of nice, right? You just put those parentheses and then just fill in A, B, B, B. Like that. And then evaluate that. Here you might have to use a calculator because those numbers get a little large. That's okay. But 3 cubed is 27, so 27x cubed, right? Now that middle number is going to be a little harder to do. What? 405? I don't know. Yeah, 135, I think. Yeah, because this is 3 times 9 is 27. 27 times 5, 135. Yeah? 135 x squared. Right? How about the next one? Yes, 225, because you have 9 times 25, so this is 225x and minus 120. And again, there's nothing you can do to combine them or anything else. This is it. This is the answer. Is that right?
So with the answer, would this almost be like the dimensions of what?
Well, no, this is just, let's say you want your volume to equal 17 or whatever, or whatnot. And sometimes it's helpful to expand it. You don't have to relate it to volume. It might just show up in other applications. But the way I like to think about this, when you're squaring things like that problem, it's just like doing 10 push-ups. Now, when you do this problem, it's about 20 push-ups and you clap after each one. So it's a little harder, extra dimension, works different muscle group up there, and it's just, that's how I look at that. That's just a bunch of fun exercises. Puzzle solving and critical thinking skills, that's really what it's all about. Helps with the decision making. Your brain process things a little faster. Just leaner brain, that's really what's going on here. Okay, so you want to see the pattern? Yeah. Good. I like that. How many of you heard of this thing? Pascal's triangle. Maybe Pascal's triangle. 1, 2, oh good. Now how do you build one, for those of you who heard of it? You start with 1, 1, 1, and then you always go 1, and then this number would be the sum of two numbers above. So what do I put here? 1 plus 1 equals 2, and that's, again, 1. Now if I go to the next line, I'll put 1, and then if you add 1 and 2, we'll get 3. Have you seen that?
Yeah, I lived there.
But do you understand how I'm building it? 2 plus 1 is 3, and then you always end with 1. You start with 1, you end with 1. So tell me the next line. 1, 4, 6, 4, 1. Tell me the next one.
1, 5.
Right? So you see, all I'm doing, I'm adding two numbers to get the one on the bottom. So 5 is 1 plus 4. 10 is 4 plus 6. 10 is 6 plus 4. 5 is 4 plus 1. And 1 is just there. So if I want to do it again, 1, what's next? 6, because it's 1 plus 5. Then what? 15, 20, 15, 6, 1. Okay? So what this does, first of all, this thing helps us to count in a very peculiar way. Basically, if I had 6 students in this class, okay, hypothetically speaking, if I only had 6 students, and I want to say I'm going to give out 2 A's, and that's it, only 2 A's, randomly. I'm just going to randomly pull your name out of the hat and give that person an A, then pull another name out of the hat and give that person an A. Out of 16 students, I'm sorry, not 16, out of 6 students, there will be 15 ways of doing that. It's kind of weird, but there's some probability counting crap. So there's one of the applications of this Pascal triangle. Don't worry about it. The other application of the Pascal triangle, there are some formulas that we already did earlier, right? What are the coefficients Oh,
B cubed.
yes, cube. Thank you. What are the coefficients on this formula, on the square formula? What's in front of a squared? 1, 2, 1. What are the coefficients in front of the 1? And we have a line that has 1, 2, 1, and we have a line that has 1, 3, 3, 1. Right? So this line would be the squaring, so the power 2. This line would be for the power 3. This line will be for the power 4. This line for power 5. This line for power 6. So those things give us the coefficients in front of all the terms. So this would be the power 1. If I just go a plus b to the power 1, that's just a plus b. The coefficients are 1 and 1. This would be power 0. That's 1. What happens when you raise things to the power 0? What do you get? 1. So anything to the power 0 is 1, so you just get 1, so 1, good. But, alright, so we got the coefficients, and that's the hardest part, to get the coefficients. The easier part is to get all the terms. Now look at the pattern on these two formulas. For the square formula, when you have a square, you start with a to the highest power that's written here, so it's a squared. And then you reduce the power of a as you go along, and you increase the power of b as you go along. So you see a went from 2 to 1 to 0, it's gone. While b went from 0, 1, 2. So you decrease the power of a by 1, and you increase power of b by 1 as you go along. Look at the next line. A cubed squared 1 gone. So you see I'm gradually dropping the power of a. 3, 2, 1 gone. While with the b, no b, 1, 2, 3. So I'm decreasing a, increasing b. At each step, the sum of all exponents is 3. Okay, you see that? 2 and 1 is 3, 1 and 2 is 3. So dropping a, bumping up b. So if I wanted to do a plus b, let's say to the power 6. So I would, don't worry about the coefficients. I have the coefficients. They're here. So I will start with a to the power 6, the highest power. Okay? Then I put a plus. The coefficient now is 6. That's what this tells me. So it's 6. Reduce the power of a. So that becomes a to the 5th. And introduce a b. So drop a, bump b. Reduce a, increase b. So tell me what will be the next step. What? A to the 4th, b squared. What is the coefficient? 15. So again, reduce a by 1, increase b by 1. So a became 4, b became 2. What about the next step? Plus 20. A to the 3rd, b to the 3rd. So the coefficient is given by the Pascal's triangle. Reduce b, reduce a, increase b. So what's the next step?
Plus 15, a squared, b.
Right. Reduce a, increase b. At each step, the sum is always 6. What's the next step?
Plus 6, a, b to the 5th.
And finally, I'll never ask you to do that. Nobody cares. But just in case, it's kind of a fun fact that you can build those powers. I can do a plus b to the power of 15. I'll just have to run this Pascal triangle for a while. So I get the line for the 15th. It'll be very long. Right. Fun. Yeah, it is fun. But this is, but look at that. Look at this line right here. Remember I was telling you something about 6 students, and I'm going to give 2 of them an A and 4 of them a B, let's say. So here's the 2 A's and 4 B's. How many ways can I do that? If I write it out, if I write it as A plus B, 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 A plus B 6 times, and I do the big FOIL, and I'm not going to combine it in like terms, because I'm silly. In that final line of all those terms, I will have 15 a squares plus b to the 4th floating around. And if I don't even write a squared b to the 4th, I'll write A, B, B, A, B, B type of thing. There'll be 15 ways I can rearrange the, okay, I don't need the last one. If I ask you, give me all different ways to write this sentence. A, B, B, B. Well, without exponents. In any different order. Want to play that game? I'll end up with 15 options, by the way. I'm just because I know 15. But what can I do? I can do A, B, A, B, B. I can do A, B, B, A, B. I can do A, B, B, B. I'm losing a B somewhere, right? I lost the B right away. B, A, B, A, B, 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 A. That's already 5. And I haven't moved the front A at all, right? These are just different orders. If I keep going, let's move. Oh, man, my brain is going silly on me. B, A, A, B, B, B. B, A, B, A, B, B. B, A, B, B, A, B. I'm actually recording this, so this is fun. Is that right? These are all different, right? I'm just moving that second A. I can do that again. B, B, A, A, B, B. B, B, A, B, A, B. B, B, A, B, B, A. Is that right? Okay. How about B, 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 A, A, B? B, 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 A, B, A?
Kind of curious with the A's and how you have the A's and B's, so each A and B have its own individual number, so.
Well, not yet, but it could. Okay. I don't know, I'm losing count. And it's probably the last one will be B, 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 A, A. That's the last one. So that's 15. So there are 15 ways I can rearrange that. The fact that I can do that without writing it out allows some companies to sell you your insurance policy. The fact that they can count really fast, therefore they can predict your chances of getting in a car accident on the intersection of Lincoln and whatever. So that's probability. Ability to count really fast. So before, because there a formula that produces that 15 without writing the Pascal triangle as well. And the fact that we can do it fast is very helpful. Otherwise, we'll just be, I don't know, in the happier society.
And so with
No
that,
insurance companies, yeah.
oh, sorry there, with that one, you're using the 15 because you said you wanted to give 2 students like A's, so
Yeah.
that's why if you wanted to give 2 students like 3 A's, you'd use.
Yeah, I'll have 20 options for that.
Okay.
If I have pick 6 students, and then I gave 3 A's, 3 B's, there'll be 20 ways of doing that. And if I said I want to give 1 A, well, that's 6 ways of doing that. It's either you, or you. So there are 6 ways.
Okay.
And if I give no A's at all, then there's only 1 way of doing that. No A's. Everybody gets a B.
So you have a probability of 1 out of 15 of being the one to receive the.
Well, 2 out of 15, because you get 2 A's. Yeah. Just randomly, if I were that psychotic, just randomly giving out A's,
Yeah.
then your chances in a group of 6 would be 2 out of 15 to get an A. Pretty slim. All right, fine. All right, here's the worksheet.
You ever see the on Khan Academy